Hey guys, welcome to the 10.2 video. This one's going to be about nets, and we'll finish up talking about different types of 3D shapes before we look at some nets. So as a review, what you should have kind of written down before, it says what is the main difference between prisms and pyramids? And if you think about it, a prism, as you can see up here, should have two identical bases. So that bottom one there and then the top one. They should be two congruent bases. Pyramids only have a bottom base. There's no counterpart on the top of it. So pyramids always come to a point. So those are some of the differences. Prisms have two congruent bases. Okay, and then pyramids only have one base. Okay, and we always name prisms and pyramids by the shape of their base. So what you can see that I've highlighted, this top left one would be a rectangular prism and the right one would be a triangular pyramid. Careful on labeling pyramids though, because if you see a pyramid like this, a lot of students or a lot of people want to call this a triangular pyramid. And that kind of makes sense because there's a triangle right here. Okay, but we always label pyramids with the shape of their base. So that would be a square pyramid. All right, so that's a little bit of a review of everything we've talked about so far, but now kind of on to 10.2 and nets. So before we write anything down, I just want to show you some different types of nets. So here we go. Full screen. Okay, so here's a couple nets that you'll see. I'll show you the 3D figure and then the net that goes with it. So let's start with, how about this guy right here, a cube. Okay. As you can see, there are, if we count up all the faces, edges, and vertices, we have 1, 2, 3, and then 4 faces around the side, and then the top and bottom makes it 6. So 6 faces. If you see the bottom 4 edges and the top 4 edges, and then we have all the sides. So there's actually 4 edges on top, 4 edges on bottom, and then the 4 around the sides, kind of connecting each one. So 4 times 3 would be 12 edges. And if you count up all the vertices, it's all the corner parts. So 4 on top, and if you flip it over the green side, 4 on bottom. So 8 total vertices. But a net means what happens if you take this shape. I'm sure you've probably seen types of things like this before, where if you take this shape, and if you could imagine cutting apart all the sides, but leaving them connected. So if I just kind of open my box lid and then fold it down, okay, if that would still be connected. Now I could cut around here and open it up, and then obviously cut around here and fold it down. So a cube, we had 6 faces. Now we need to make sure that we have 6 faces in our net. So here's your cube, and here is the net of a cube. Okay, so we'll start with this shape here. Once again, we have another cube here. So if you look, the shape's going to unfold in a second here, but this is your cube. Once again, 6 faces. If we unfold a couple different parts, the sides, and here's the top, we can fold that top over. There's actually a top and a side together here. So without this top part, here's your bottom and here's your 4 sides. Here's your top part. So if you fold it back up, you can make your cube. Okay, and that's the net of a cube. Now you don't have to just have it like that. You could have written your net like that with the top part on the top there, or you could put the top over here. There's lots of different ways you could do it. Okay, so let me show you some other different nets, and we'll kind of draw some. Let's start with this one right here. If you could classify this shape, it has 2 triangles on top and bottom, or one on top and the one on the bottom. So this is actually called a prism because it has 2 congruent bases on top and bottom, and then there's rectangles around the outside. So this is actually a triangular prism. All right. And here's the 3D version, or the net of it. If we start with a triangular prism, you can see that the red one's just a little bigger. What we can do is unfold the top base, unfold the bottom base, and kind of see through it now. If we put it down, there would be the top and bottom bases, and then the 3 triangular sides. So they unfold that way. And you'll be able to see these in class and kind of experiment with them and touch them and see for yourselves how they actually work. So in a prism, you have two congruent bases, and then your rectangular faces. So notice there's 1, 2, 3, 4, 5 different shapes in your net. And then in the shape, 3D shape, we have 1, 2, 3, 4, 5. So that always works out. Let's show you a different one. About this guy right here. Should have shown you the 3D shape to go with it. But if we look at this, we have 4 triangular sides and then this bottom part. If there's one shape that's all by itself, that has to be the base. So that would be the base. And then you can kind of see the triangular sides are going to fold up. Why don't I do it this way? They'll actually fold up this way. So this triangle will go down there. The other triangles will kind of fold around. And what you form is a pyramid there. Okay, and it's actually a square pyramid because the bottom is a square. So that's actually the net of a square pyramid. Now this isn't the only way to draw this net. We didn't necessarily have to unfold it just like that. We didn't have to cut it from the top like that. We could have cut down each of these sides. So without me showing you that right now, I want you to think about how would that look like if you cut down each of these sides. Okay? And what would that make the net look like? Because this is probably not the most common net. So there's that shape again there, the 3D shape. Okay, next shape. We'll do a couple more here. Could you classify what this shape is? Okay, we have 4 different triangles. It's got to have 4 sides. And if we fold up these sides here, you'll see that, I mean, it looks like a triangular something for sure, but if it has one base and all the sides there, that works out.
Good evening.
Okay, here's Mr. McDaniels on the announcements. Conferences are over. I'm going to keep talking through him, okay? Next one we have is a rectangular prism. 4 different sides. And here, and here. Ooh, I get to wear jeans tomorrow. All right. Okay, so there is the rectangular prism. Okay, notice 6 sides. 4 of them are equal, and 2 of them are equal. These are the bases. Everybody's favorite one, a cone. You always want to know what that looks like. How do you unfold a cone? Well, here's how it works. Here's your base, and it actually goes around like that, around the outside. It's kind of a weird shape for that one. And then we have a cylinder. So cylinders is probably the one we'll talk about more tomorrow for sure. But it actually, if you cut apart a soup can or a label, you can actually take this home and, take a label off of one of your vegetable or soup cans. Okay, I'm sure your parents wouldn't mind, as long as you tell them what it is. And then you actually unfold the top, unfold the bottom, and the rectangular part actually comes out. What I want you to think about is the distance between my 2 fingers and the part on this circle. See how they would actually line up with that? The width of my rectangle goes all the way around that circle and forms that circle. And it forms the circumference of that circle. So all the way around, if we unfold this and stretch it out, from here to here represents the base of the rectangle, but it's also the circumference of our circle. And that's going to be important later on. So that's pretty much most of the shapes I wanted to show you. What I'd like you to do now is just kind of go back and look at that one website from yesterday that I posted about the different 3D shapes, and I'll put it on the website for you on Schoology. But there are definitely a couple other things we want to look at here. Not too much here, but if you could just go ahead and describe in your own words how to make the net of any 3D shape. So kind of what we did was cut them apart, unfold them to make our new shape. Sorry, I lost my pen. Okay, we're good now. All right, so we want to describe how to make the net. You can kind of write whatever makes sense to you in your own words, but you want to cut apart the edges of any 3-dimensional shape. Okay, then you want to unfold them. Unfold the cuts there to form a 2-dimensional net. So if we name I'll give you a second to write that down. If we name the shapes under here, we can name the nets here. Here we have our bases that are congruent here. Okay, and those don't have to be the only bases. You could have different bases as well. You could have made any of those actually the bases, depending on your orientation. But this one here is a rectangular prism. Okay. The next one, if we look at the two triangles here, those are going to be the bases when they're folded up, and these will just be the sides. So this is actually a prism because it has two equal bases, and it's a triangular prism. The next one is our two circle bases. The only one that has two circle bases, top and bottom, is a cylinder. And the last one, if we imagine folding these ones up here, the bottom part would stay there. The top parts would all come to a single point in the middle there. This would kind of come right down to the center there. This would be a triangular pyramid. Okay, so those are the different nets, and you'll be able to look at those and draw them in your own 3D booklet. But what I want you to do on your own is draw two different nets of a cube. So I'll do a standard one for you. We have 1, 2, 3, 4, 5, 6 different parts. That's kind of ugly there. Sorry about that. Try to make it a little better on your own paper there. But that's one way to unfold a cube. Try to come up with another way on your own there. And if we do a different net of a triangular prism, the standard one would kind of be to unfold your triangle. Ooh, those should be equal. Unfold your triangle, and then actually have your other parts there. So that's one way to do your triangular prism. See if you can come up with a different way to do the net of a triangular prism. And that's all, guys. We'll see you tomorrow and talk more about nets. Have a good day.